We're back. It's Ham Radio Perspectives. I'm Quinn, K8QS.
And I'm Tom, W89TDD.
Tom is having some bandwidth problems down there in rural Indiana, so we'll see how this goes. We just aborted one recording because it was so bad. We're still trying to get you part of that 4 trillion or whatever that was earmarked for rural bandwidth, but it doesn't seem to be coming.
I should live so long.
That's a great expression. Okay, so we've been in the hobby a long time. We're trying to pass along just a little bit of wisdom for some folks, and this has to do with antennas. We're going to look at some antenna essentials. We've got 10 things just to think about with all antennas, although we think about them mostly with HF antennas. It's basic antenna stuff that you need to know if you don't already, and we can have some fun with it too. What's number 1, Tom?
Well, number 1, Quinn, is the resonant length and frequency. Right. How do they affect each other? Yeah, an antenna is most efficient when its physical length matches a specific fraction of the radio wave's wavelength. For a standard half-wave dipole, for example, the formula for the total length on feet is roughly 468 divided by the frequency in megahertz. And if you're operating off resonance, now that's going to lead to a high standing wave, lose power, and generate harmonics.
Been there. We used to get those harmonic official observer reports when we were growing up in Chicago, because we had signals going out that were not just on the frequency that we thought we were operating. So that's number 1. Number 2 is, again, getting back to this SWR, we want to try to get the lowest standing wave ratio we can. If we can't get the lowest one at the antenna feed point itself, at least get it low in the shack for the rig using an internal or external antenna tuner. And we'll put a link to another video we've got that's coming up here on antenna tuners and all. So this is very important. Get that SWR down. If you've got the newer solid state rigs, it's essential.
All right. And number 3, need to consider the height the antenna is above the ground. For example, for a horizontal antenna like a dipole, height is everything. You want to achieve a low takeoff angle if you want to work some long distance, DX communications. The antenna should be at least a half wavelength, and then you can calculate that with a 468 divided by the frequency above ground. If it's too low, most of your signal is going to go straight up. And this is a phenomenon called near vertical incident skywave. Essentially, you're just turning it into a cloud burner, but you'll get good local coverage, but really poor DX. Verticals work better in the air with radials unless you have a fabulous ground system. And we both used wire antennas low to the ground with some success. And, Quinn's perennial story about the 150-foot tower.
2
as a
2 towers,
5/8 vertical.
Yeah,
at the University of Illinois.
Yeah. We had 250-foot towers, which were used by the broadcast station, AM broadcast, and then they moved their antennas out of town. So we inherited those towers. Those are wide base 150-foot towers. One of them we tuned up as a vertical, 5/8 way vertical on 80 meters, but then we also had a dipole across the practice football field from 150 foot to the other. And you can imagine how that operated, talking about getting it high in the air. So number 4, Tom, let's talk a little bit about an area where there's a lot of disagreement among hams, or some disagreement, and that is about the antenna polarization. How is it polarized? Is it horizontal, like this, or is it a vertical antenna sticking up like this? And you'll find people that have strong opinions about whether you should use horizontal or vertical. Now, horizontal antennas generally have the advantage of being quieter. They don't pick up as much noise, especially noise around the neighborhood. And they tend to be good for long distance propagation if you can get them up in the air a little bit. They're good stuff. Now, the verticals, on the other hand, tend to pick up a lot of local noise. So if you're in an urban area and you put a vertical out there, you're probably going to get a lot of noise. The LEDs from your neighbor and the guy with the fish tanks, he's got a heater in there, and you're picking up all of this stuff, more and more of it around. And it becomes a real problem. We say that vertical antennas are noise magnets in suburban environments. Now, what's interesting about this, Tom, and I want to get your opinion on it, is that CBers, of course, for a long time on their cars, they would have a 102-inch whip for their cars around town. So what they began doing is putting their Yagi antennas vertical, so that using ground wave, they would be able to match the antenna on the car, which is vertical, to their beam antenna, which was vertical, figuring that they would get better coverage that way. And hams never got into that too much, but that's what CBers tended to do. And hams go with the horizontal Yagis. What are your thoughts about that, Tom?
Well, the classic with the CBers with the 102-inch whip on the back of the car was to go to a parking lot, back up to a spun aluminum light post, and use it to focus your antenna as a vertical Yagi, essentially.
Pick up a reflector
to work some DX, right? And the utility pole acted as a reflector. So, but yeah, most CB is vertically polarized because of the fact that your car has a vertical antenna on it. And back in the days, I remember that they used to run cubicle quads.
Loved it.
Up at about 30, 40 feet. And for working skip DX. But
what about feed line, Tom?
Well, feed line choice, that makes a difference too. You got coax, you've got lateral line, or sometimes called window line, or just two parallel wires running from your tuner to the antenna. And while coaxial cable like RG8, RG58, LMR 400 is a standard for easy use, lateral line, or sometimes called window line, is much lower loss when operating an antenna off resonance. For example, if you use a single doublet antenna for multiple bands, lateral line paired with a balanced tuner is often the most efficient setup. Window line, however, has weather issues. Quinn used cable company 75 ohm for some dipoles.
I did.
When the company left the spool in the yard, and I have some also. And actually, it works well, with minor tuner adjustments. As a matter of fact, I've converted a lot of my PL259 connectors to F connectors in the back of my radio, so I can run 75 ohm line, because it's ubiquitous. It's everywhere. If you go to a new housing development, they generally leave a scrap 500-foot roll laying there. When they move out, then move all their junk out. So, you can pick it up pretty cheap, but it is an effective way to go if you really want to be cheap about it. So
yeah, I always had trouble, Tom, getting PL259s with the right, not shield, what do you call it? The right thing that goes in the connector to fit the coax.
Okay, what I use is I use a regular F connector, which is made for 75 ohm line, but they have a converter that'll take a 259 on one end and an F connector on the other end. So I take that 259, screw it into my coax connector on the back of the rig, and then screw the F connector into that. Works fabulous.
Okay, that's a good tip. Now, sometimes you are going to have a difference in, the SWR is high and your antenna and feed line, and they may not be matched. And you can do some work with the tuner. We'll talk about in the other video on antenna tuners. But the simplest thing, typically, if you have an unbalanced to balanced antenna, coax is unbalanced, the antenna is balanced. It's two wires, same length, balanced. And historically, you'd feed those with two wires, one to each side, and coax throws that off. So what do? You get a balun, that makes the balun, the balanced to unbalanced connection. and you can buy a balun. They can be fairly expensive or cheap, depending on the amount of power you're buying it for. You locate that up where you feed the coax into the antenna, or you can take a bunch of loops of the coax, maybe 10 or 12 loops right at the antenna where you're feeding it, and tape those together, or somehow connect those loops right there. It does make it a little bit heavier to pulling down on the center of the antenna, but if you've got something like an inverted V form like this, where you're feeding it up on top and the top is hoisted, then it just adds a little bit, and it's not going to be sagging real deeply. So the balun really helps, though, with keeping RF, radio frequency, out of your shack, because when you've got a balanced to unbalanced problem, some of that RF is coming back down on the outside of the coax back into the shack and causing all kinds of grief, like lights going on and off and other problems.
So, point number 7, consider the antenna gain and directivity, particularly with a dipole. A dipole is somewhat directional. It sends more signal broadside to the wire. If you want more punch in a specific direction, a Yagi or a hexabeam uses parasitic elements, and that focuses the signal, providing gain that makes, a 100-watt signal perform like it's much stronger. You can also put a wire that's not straight, like Quinn's end-fed 80-meter wire going through the trees.
Yeah, exactly. I don't know if I told you this, Tom, but back in the days when I was living in that trailer in Chicago, one of our buddies gave me a 15-meter single-band beam made by Gotham, the old Gotham company. And I said, yeah, I'll take that. I didn't know how I would mount it. So I mounted it on about 15 feet in the air at the side of the trailer. I locked it in there. The problem was I couldn't afford a rotor to rotate that thing. So I would hear a station, figure out where they were. We had call books back then, paper call books. I'd look up where he was if he didn't say so. And then I'd run outside using the Armstrong method. I would turn that in approximately the right direction. And it worked quite well, even though it was kind of low. So yeah, antenna gain and directivity, important things. Also, think about environmental interaction with the antenna. It's best if you can get the antenna up off the ground so you don't have it interacting with the ground and away from any other stuff around the area. And if it's a vertical antenna, you need to get some what we call radials under it, because those radials are like the other half of the antenna in the ground. Right. I used to think, Tom, that just by putting a piece of copper from plumbing, like 3 feet down and then attaching a vertical on the top, it's good copper, I'd get a great ground connection. Of course, I didn't look up where good ground was, and it was certainly not in my area. It was all a bunch of clay. Didn't work at all. So the FCC has a map that shows soil connectivity across the U.S., and you can see, looking at that map, we'll put a link to that down below too, what the area is like and how much you can get away with there for planning. And it's used, that map is used for AM broadcasters to find out what the soil is like and how far their signal is going to go. So the FCC regulates them with how much power they can use that would potentially interfere with other stations.
All right. So let's talk about, let's say this is number 9. Let's talk about compromised antennas. Those are the small antennas that you use for parks on the air, summits on the air, parks on the air, where you're set up. You've got to use a shortened antenna, like, some of these jobbies that's got the little tuning coil on the bottom, and you've got maybe an 8-foot whip up there, an end-fed half waves, a mag loop. While they're convenient, they usually have a very narrow bandwidth or a lower efficiency compared to a full-size dipole. You can use one basically just for receiving, but in a pinch, and I've seen a lot of results from parks on the air, they're somewhat efficient, and you can work a lot of stations. I've seen a lot of parks on the air, summits on the air that are working QRP 5 watts with these compromised antennas, but you've got to remember that the bandwidth on them is very narrow, if it's a fixed coil on it, you're not going to have a lot of latitude. If it has an adjustable coil on it, you've got a little bit more latitude as far as how far frequency you're actually going to be working. So, that's a factor of an antenna tuner, Quinn.
It is, yeah. So number 10 is the antenna tuners that don't really tune the antenna, but you're trying to get your rig to believe that the antenna is properly tuned by putting a tuner in there. And, it's a way of trying to make the whole antenna system look like it is all 50 ohm coming out of that antenna tuner and going up to the antenna, or 50 ohm back to the rig for that match. Antenna tuners are increasingly important today, and people use them. The fact of the matter is that the newer rigs, the solid state rigs, really can't handle high SWR the way the old vacuum tube rigs could. So we use these to try to cut down on the amount of loss and get a little bit of a match in there. So the antenna tuner, take a look at the link down below. We have to a whole video we did on antenna tuners. That's an art in and of itself. Thanks for watching. This is 10 essentials about antennas. We hope it helps some of you that are newer to the hobby, or maybe we hit on a particular point that you didn't know much about. And we are grateful that you're watching. Please subscribe, ring that bell, and all that other stuff. This is Ham Radio Perspectives. I'm Quinn, K8QS.
And I'm Tom, W89TDD.
73, everybody.